So yesterday's data was how long each of us lived in Pomona, I think, that we did. Earphones off right now. This data is the age range of a college class. So this is some specific class at a college, and this is the age range of the students. When you guys get to college, by the way, this is a typical age range. I have students like this, especially graduate school, upper division classes. You get students in 30-year-old and stuff. It's a cool environment. I recommend college. It's fun interacting with your peers on important topics, study different subjects, interacting with professors, classmates. It's great. It's not stupid like high school, where everyone's trying to be cool and cracking jokes and not taking things seriously. When you get to college, you can really apply yourself and get into what you study. It's pretty fascinating. I recommend it. Let's do the 5-number summary now as yesterday. So yesterday was the 5-number summary is how we create a box plot. What was the first number in the 5-number summary? Did they tell me from yesterday? On your notes. The first number is what? The minimum. What's after the minimum? What is? Perfect. What's after quartile 1? Ortiz. Thank you. What's another name for the median? Mr. Pinello. Nice. So there's the first 3. What's the third one, Austin? Actually, the 4th number in our 5-number summary. Close. Were you here yesterday? Okay, you just watch the notes later. Rodriguez, what's the 4th number? Close. That's the 5th number. There's something before the max. Exactly. Quartile 3, and then the max. So there's our 5-number summary. So far, so good. Move this down a little bit so I get some room here. Okay. First things first, I got to put these in order, huh? So let's put these in order. 18. 18. I got how many 24s here? Actually, 2 22s. 22, 22. I got 24. I got 3 25s. Yep, 3 25s. So I'm putting them in order right now. I got a 27, a 28, and 3 30s. 27, 28, and 3 30s. We're rocking and rolling. Cool. So we're putting them in order from least to greatest so we can find our 5-number summary. So the minimum obviously is going to be here 18. So I'll put 18 for my minimum. I can't find quartile 1 yet until I find the overall median. I could find the maximum just by looking at the data. It's going to be 30. That's easy. Cool. All right. So far, so good. All right. Let's find the median now. Before we find quartile 1 and quartile 3, the median, the exact middle number. We have 2, 4, 6, 8, 10, 12 data values. So the median is going to be in between the 6 and the 7. 1, 2, 3, 4, 5, 6. So the median is going to be in between these two data values, the median. 25 and 25. What number would be in between 25 and 25? We'll just add them up. It's 25 plus 25 is 50 divided by 2 is 25. So the median is 25. Now we've got to find quartile 1 and quartile 3, and we're ready to rock and roll our box plot. So quartile 1 is the quarter of the data. What data value is a quarter of the way into the data? So all the numbers to the left of the median, okay, the median is 25, so these 6 values to the left of the median, what would be the median of that? That would be quartile 1. And then these 6 values to the right of the overall median, what would be the median of these 6 numbers? That would be quartile 3. So I'll put it in green for now. I got 6 values, 1, 2, 3, 4, 5, 6. Therefore, quartile 1 is going to be right in between 22 and 24. So we find the average of 22 plus 24. Add those puppies up, they'll be 46. Divide by 2, 23. So there's our quartile 1. Question so far? And then quartile 3 will be in between the 28 and 30 right here. Here's quartile 3. 28 plus 30 is 58. 58 divided by 2 will be 29. Huh? So quartile 3 is 29. Question so far? We have our 5-number summary now. Minimum, quartile 1, the median, quartile 3, and the maximum. We're ready to draw our box plot, box and whisker plot. Do it. Okay, here we go. I notice that my lowest value is 18 and my highest is 30. So when I make my number line, I'm just going to go by ones. Not too bad. I'm not going to go by 2. So remember, first thing we do is draw a number line. Start with 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 30. All right. Rock and roll. Let's draw our box and whisker plot now. Let's first draw the box. Where do I begin to draw the box? Where does the left side of the box start? Can someone tell me from yesterday? Where does the left side of the box start? Anybody? The left side of the box. Where would I begin drawing the left side of the box? Where? Good try. That's where I start the whisker. Where do I draw the left side of the box? Quartile 1. I begin at quartile 1, which is 23. So 23 is right here. So I draw the left side of the box. Where do I end the box? Can someone tell me besides Rodriguez, where do I end the box? I'm drawing the box here. Where does the box end? Someone besides Rodriguez. Where? Good. Quartile 3. End at quartile 3 is 29. Very good. So I'm going to draw the box rectangle all the way to 29. Kind of a crappy looking box, but yeah. Awesome. So we start box. You'll watch the lecture from yesterday. Coming up. All right. We draw a line inside the box representing the median, right? So the median is 25. So let me draw a line right here at 25. Now for the whiskers. We'll draw the left whisker. The left whisker goes from quartile 1 all the way to the minimum. So here's the minimum right here. We draw the left whisker. The right whisker goes from quartile 3 to the maximum, the small little whisker. And our box plot. Box and whisker plot. All right. So let's give it a title. This is age of college, age of students in the class. That's what the numbers mean. You gotta specify what the numbers mean here. In this case, it means the age of the students in this college class. All right, here we go. So this box plot gives a scientist an idea of where the data is hanging around. What percentage of data is hanging around where? Watch what I'm going to do now. You're going to mark your. We're officially done, by the way. This would be a done box plot here. We're done. What I want to do is mark up our box plot and give you some features of every box plot that's true of every box plot. No matter what the box plot looks like, how stretched out and how small the whiskers are, how long the box is, what we're going to mark in now is true for every box plot. Ready? So on your notes, every time we have a box plot, from the minimum all the way to quartile 1, the little bracket, every time you have the minimum to quartile 1, that's always going to be 25% of your data. Always. So it gives a scientist or a statistician, a researcher, like, okay, 25% of my data is from between 18 and 23 of age. 25% of the class is between 18 and 23 years old. The box, the whole box itself, which is from quartile 1 to quartile 3, look at the box, is always 50% of your data. Always. So half the data of these students in this college class are between 23 and 29 years of age. So it's kind of useful. You kind of see how the data is behaving. How much percent is left? So that's going to be right here. Look at the distance between quartile 3 and the maximum. That's 25% of the data. Think about that. So 25% of the class is between the ages of 29 and 30. %25 of the class is 29 to 30 years old. Was that true? Let's see. Yeah, look at it. There's 3 students that were 30 years old. That's 25% of the data. So we get 3, and 3. That's a quarter of the data, 25%. So you can see how it's true in the box plot. 50% of the data are students from age 23 to 29. 25% of the data is from 18 to 23. So this goes for every box plot you'll ever see. So it gives a scientist, like, hey, okay, the data's hanging around here or here. A good amount of, look at 25% is just in between these two values. That tells the scientist pertinent, significant information about the data. Okay. Now, questions so far? Questions. By the way, obviously, everything to the right of the median would be 25%. Right? This part would be 25% of the data, and this part would be 25% of the data. obviously, because this would be the median, exact middle, that little line, little FYI. Okay. Now, what we're going to do now, you have an opportunity for extra stamps.